Okay, this is chapter 17, the urinary system. As you continue to learn more about the structure and function of the body, the concept of homeostasis remains as a critically important and unifying theme. First introduced and emphasized in chapter 1, the concept of homeostasis has served as the glue that has allowed you to connect information about specific cells, tissues, organs, and organ systems presented in every chapter of this text. Understanding of the body as a whole. The constancy of blood fluid volume and levels of many important chemicals required for normal metabolic activity in every cell of the body depend on normal urinary system functions. Therefore, the urinary system plays a key and central role in maintaining homeostasis in the body as a whole. One function of the kidneys is to clear or clean up the blood of the many waste products continually produced as a result of the metabolism of foodstuffs in the body cells. As nutrients are burned in the cells for energy, the waste produced soon enter and then must be removed from the blood. Some of these waste products are cleared from the blood by kidneys and must be quickly excreted in the urine, or they rapidly accumulate to toxic levels. This is a condition called uremia or uremic poisoning. The kidneys also play vital roles in maintaining production of adequate RBCs, blood pressure, regulates electrolytes, water, blood, pH levels, and acids, bases in the body. To locate the kidneys on your own body, stand erect and put your hands on your hips with your thumbs meeting over your backbone. When you're in this position, your kidneys lie above your thumbs on either side of the spinal column, but their placement is higher than you think. The right and left renal arteries emerge directly from the abdominal aorta at a level between L1 and L2, that's your lumbars in your spine. Both arteries are short but have a relatively large diameter. Normally a little more than 20% of the total blood pumped by the heart each minute enters the kidneys. The rate of blood flow through this organ is among the highest in the body. This is understandable because one of the main functions of the kidney is to remove waste products from the blood. If you were to slice the kidney through from side to side and open it like the pages of a book called a coronal section, you would see the structures shown in 17.2, identifying each of the following parts. The renal cortex is the outer layer part of the kidney. The word cortex comes from the Latin word for bark, so the cortex of an organ is its outer layer. Renal medulla is the inner portion of the kidney. The renal pyramids is the triangular divisions of the medulla of the kidney. Extensions of cortical tissue that dip into the medulla between the renal pyramids are called the renal columns. Renal papillae, or papillae, which is a plural, is the narrow innermost end of the pyramid. The renal pelvis, also called the kidney pelvis, is an extension of the upper end of the ureter, the tube that drains urine into the bladder. The calyx, or plural calyces, a division of the renal pelvis. The papillae of a pyramid opens into each calyx. More than 1 million microscopic units called nephrons make up each kidney's interior. The shape of a nephron is unique, unmistakable, and admirably suited to its function of producing urine. It looks a little like a tiny tunnel with a very long stem, but it is an unusual stem in that it is highly convoluted. That is, it has many bends in it. The nephron is composed of two principal components, the renal corpuscle and the renal tubule. In the renal corpuscle, we have the Bowman capsule, the cup-shaped top of a nephron. The sac-like Bowman capsule surrounds the glomerulus. The glomerulus or plural, the glomeruli. It's a network of blood capillaries tucked into the bone capsule. The small artery that delivers blood to the glomerulus afferent arteriole is larger in diameter than the blood vessel that drains blood from it, efferent arteriole, and that it is relatively short. This explains the high blood pressure that exists in the glomerular capillaries. This high pressure is required to filter waste from blood. The renal tubule is the proximal convoluted tubule. The first segment of a renal tubule is called proximal because it lies nearest the tubules organ from the Bowman's capsule, and it is called convoluted because it has several bends. The nephron loop is the extension of the proximal tubule. Observe that the nephron loop consists of a straight descending limb, a hairpin loop, and a straight ascending limb. And to ascend is to go up, and to descend is to go down. The distal convoluted tubule, the part of the tubule distal to the extending limb of the nephron loop, is the extension of the extending limb. And then the collecting tubule is a straight, that is not convoluted, part of the renal tubule. Distal tubules of several nephrons join to form a single collecting tubule or duct. The renal corpuscles, the glomeruli, surrounded by the Bowman capsule, and both proximal and distal convoluted tubules are located in the cortex of the kidney. The medulla contains the nephron loop and collecting tubules. Urine from the collecting tubules exit from the pyramid through the papilla and enter the calyx and renal pelvis before flowing into the ureter. Okay, now the function of the kidneys. They're obviously vital organs, but the function they perform, that of forming urine, is essential for homeostasis and maintenance of life. Early in the process of urine formation, fluid, electrolytes, and waste from metabolism are filtered from the blood and enter the nephron. Additional waste may be secreted into the tubules of the nephron as substances useful to the body are absorbed into the blood. Normally, the kidneys balance the amount of many substances entering and leaving the blood over time so that normal concentrations can be maintained. In short, the kidneys adjust their output to equal the intake of the body. By eliminating waste and adjusting fluid balance, the kidneys play an essential and important part in maintaining homeostasis. Homeostasis cannot be maintained, nor can life itself, if the kidneys fail and the condition is not soon corrected. Nitrogenous waste products accumulate as a result of protein breakdown and quickly reach toxic levels if it is not excreted. If kidney function ceases because of injury or disease, life can be maintained by using an artificial kidney to cleanse the blood of waste. Excretion of toxins and of waste products contain nitrogen, such as urea and ammonia, represent only one of the important responsibilities of the kidney. The kidney also plays a key role in regulating the levels of many chemical substances in the blood, such as chloride, sodium, potassium, and bicarbonate. The kidneys regulate the proper balance between body water content and salt by selectively retaining or extracting both substances as requirements demand. With that being said, I have to go urinate right now. Maybe I do have to, maybe I don't. What's it to you? Alright, anyways, I gotta study this, so see you later.